So now let's talk about some security technologies. There's a lot we can talk about with regard to encryption and all kinds of security technologies, but let me give you a very, very brief overview of it. The objectives for any kind of security technology generally fall into four categories. One is confidentiality. That's what people normally think of about security, is I'm sending data to you and I want to encrypt the data so that nobody can listen to that data. Only you can get access to that data. The second one is integrity. I want to make sure that the data has not been tampered with. And that involves making sure that if the data is changed, that you can detect that there's a change. The other one is identity. I want to make sure that when you send me the data, that it actually came from you and not from somebody else. And then something else, which is a word perhaps you have not heard of, which is non-repudiation. And that's similar to a signature. If I sign something and give you approval, for example, to spend money, you don't want me to be able to claim that I did not sign the data. That's called non-repudiation. It's a signature. So let's dive into some detail here, and let's talk about cryptography. I view cryptography as being the engineer that built the airplane, and I view applied cryptography as the pilot that's flying the airplane. There's a lot more pilots than engineers in terms of the people that you see. So with cryptography, we're really going to focus on the pilot. There's a lot of companies that build cryptography. For example, Renesas builds security chips. We're going to cover that chip with what we call applied cryptography. We're not going to get into the details of how the security works. The pilot doesn't know all the details of how the plane works. The pilot knows how to fly the plane. What are some of the objectives with applied cryptography? Again, not focusing on the details of how it works. You put some data in and the encrypted data comes out. It's that simple. And what are some of the things you want in an applied cryptography? You want to have clear interfaces. You want it to be well documented. You want to understand what's the difference between logical security and physical security. Does my chip provide physical security? Yes or no. Is it FIPS certified? Yes or no. Keep it very, very simple. You want to know what platform does it run on? And what is its price performance characteristic? All the details you read in the journals about security technologies and cryptography are generally not important to the pilot, to the person designing the system for security. So we're going to talk about two kinds of security. One's called symmetrical and one's called asymmetrical, and we'll get to exactly what that means in a minute. The first one is the simplest form of security, which is symmetrical encryption. And if you ever had a little wheel a little encryption wheel when you were a kid, this is what symmetrical encryption is. And the idea here is that there's two parties that are sharing information. Now let's take an example. You have a host and a peripheral. And say the host is trying to send some data to the peripheral that's encrypted. So what happens is both parties have the same exact key. That's why it's called symmetrical. It's the same key. And the way we do encryption is we apply an encryption algorithm. And again, we're pilots, we're applied cryptographers. We don't really know or care how the encryption works. Is that we use this key to encrypt and decrypt data. I encrypt data with my key and you decrypt data with the same key. Very, very simple. The next one is authentication. We can use the same technology to do an authentication. So I want to make sure this peripheral is trusted before I send it any data. And so this peripheral has a key, and this peripheral has to prove to me that it has the key without releasing the key. I can't ask for the key. If you give me the secret and you whisper the secret to me and somebody's listening, then that secret is now let out. And the idea is if we all have the same key, then we have a problem because now that's been compromised. So the way they do that is I do what's called a random challenge. And that's very similar to if you had a friend and you're talking to them, say over email, and you don't know if it's really them, you'll ask them a question. That's called a challenge. What did we do last summer? What's your sister's name? And the idea there is that you have to ask a different question every time. And therefore you know that's the person. And so that's basically how challenge response works. But instead of asking questions like who is your sister, you're going to send it random data and use an algorithm. So you send it a random challenge, which is literally just random data. And the peripheral will take its key and encrypt the data with that key, and then return it to you in a response, and then you'll decrypt the data and make sure that the data is the same exact challenge you sent. It's actually quite simple, and you have not revealed the key. That's how authentication works. And so the key thing here to understand is that the same key is used with both parties, and often if you have multiple parties, multiple hosts, multiple peripherals. An example would be if you have a bunch of PCs out there and you have a bunch of peripherals out there and you want to make sure that your PCs only work with your peripherals, you're going to end up having the same key everywhere. And again, we're in the DVD scenario where if it breaks once, it fails everywhere. And that's why symmetrical encryption is typically not used. It's very, very inexpensive, and it's very tempting for management to want to use symmetrical encryption because it's cheap. And if they don't know how dangerous it is, sometimes they don't want to know how dangerous it is. And they can get away with it if they just claim they don't know. But we're not going to let them not know because this is so simple. We're going to explain it to them using this video. So let's go to asymmetrical encryption, also known as public key cryptography, also known as PKI. So let's talk a little bit about this. So this is a little bit more complicated, but conceptually, again, it's not really that complicated. The idea here is that, again, same scenario. We have a host and a peripheral. What happens is the host has what's called a root certificate. It's public information. It doesn't matter if you steal that information. The peripheral has a private key, its own private key, and a certificate which contains a public key. And so what happens during authentication, and the process here is provisioning, where you insert these keys, that's provisioning on there, and the process of authentication is very similar to what happens with symmetrical encryption, but it is a little bit different. First, the certificate from the peripheral is sent to the host. And what happens is the host uses the root certificate to authenticate the certificate that came from the peripheral. And the details of how that happens, we can deal with in another presentation. And so in this situation here, the host has authenticated the certificate that the peripheral gave it, and now it's going to use the peripheral certificate to do an authentication to the peripheral. So it sends it a random challenge, just like it did in the symmetrical case. And what's going to happen is the peripheral sends a response, just like in the symmetrical case, but the difference here is that the peripheral uses its private key to encrypt that data. And the host uses the peripheral's public key, which is public information, to decrypt the data to make sure that it came from that peripheral. And that's basically how it works. There's a lot of details here we're leaving out, but conceptually, this is the way it works. And now let's talk about encryption. So the way we can do encryption here is that we're going to use symmetrical encryption, because symmetrical encryption is actually much quicker than asymmetrical encryption. But the problem is, what do you do with the keys? Where do you store the keys? Well, in this case, what we actually do is we randomly generate a symmetrical key that's different every time, and we send it to the host using the PKI, or the asymmetrical technology. And the details, we can do it in another presentation. That's basically how it works. So now both parties have the same symmetrical key that they're going to use for their session, and they're going to throw it out when they're done. This is basically how SSL works, web technologies, HTTPS. And now we can encrypt data back and forth. And so in encryption and cryptography, a combination of public key technology and private key technology used in conjunction to do authentication to prevent failures that are break once, fail everywhere is best practice.